Hey everyone, welcome to this video. We are going to talk about encoder only and decoder only transformers. So a quick review. We talked about how there are issues with word by word translation, right? Translating from English to Spanish as an example. And so a better way to do this would be sentence to sentence translation, which can be thought of as sequence to sequence. And when it comes to sequence, RNNs aren't perfect. In fact, we might want to use transformers with attention instead. And here is the diagram of the transformer we have learned so far in this course. Transformers were initially for sequence to sequence, turning a sequence into another sequence, such as language translation, where the encoder understands the English sense for translation, which can be thought of as just understanding language on the left-hand side, and the decoder on the right-hand side generates the Spanish sense. So at core behavior, a decoder is for generating language. However, the point of this video is that you can use the transformers encoder or decoder without using the other. So we could just use the transformer encoder by itself, or maybe you want to use the transformer decoder by itself. Let's first talk about encoder-only transformers. An encoder-only transformer we will use later will be called BERT. The attention used in encoder-only transformers can access past and future tokens / words. And remember that fundamentally, an encoder can be thought of as just understanding language. So the output from an encoder-only transformer is usable for things such as sentiment analysis, sense classification, question answering. And let's go over these three things right now. So let's say we have a sentence called, I regret watching this movie. In sentiment analysis, we have to guess if this is a positive or negative review. Most likely, this is a negative review, right? So we'll pass this sentence to the encoder-only transformer, whose core behavior is to understand language. And once it understands the language, it creates context-aware word embeddings. We'll pass this to a fully connected feed-forward neural network. And the analysis will be 25% positive, 75% negative, which is a good guess because this is most likely a negative review. What about sense classification? So we have a sentence called red team won with 4 goals. We'll pass this to the encoder-only transformer, which again, its core goal or purpose is to understand language. It'll create context-aware word embeddings that we pass to a fully connected feed-forward neural network, and the analysis will be 20% entertainment, 10% politics, 70% sports. So its best guess is that this should be in like a sports article, etc. Question answering I find the most cool out of all three. So maybe we have a context of Kevin cooked the steak for his dog yesterday morning at the park for fun. So you ask a question, why did Kevin cook? The encoder-only transformer understands language, and the answer is for fun, which is correct. Now, this might seem pretty magical, so to speak, but think of it this way. The context must contain the answer. So the answer of for fun is in our context. And another way you can think of this is that think of it as more like text extraction. So this question is a really fancy way of saying extract this text that's relevant, and the relevant text is for fun. Okay, let's now talk about decoder-only transformers on the right-hand side. Decoder-only transformers, you have probably used or at least heard of ChatGPT, Gemini, Llama. Decoder-only transformers have become much more popular over encoder-only transformers. For attention, decoder-only transformers can only access previous tokens. And the core behavior of a decoder is generating language. More specifically, Decoder-only transformers' main behavior is to predict the next token. So when we used a decoder alongside an encoder, we have the English sense we want to translate, and the decoder would generate the Spanish translation one token at a time. It would predict, okay, the next token should be nombre, the next token should be S, the next token should be Kevin, etc. But what if we had a decoder only transformer? Maybe we could use that for, say, chatting. And so it has to predict the next token. Start, hello, how are? And hopefully, our decoder only transformer is smart and predicts the next token of you, or hello, how are you? All of the amazing things we can do with ChatGPT, Gemini, etc., is just being done from predicting the next token. So far, we have learned a transformer encoder and decoder work together for language translation. Again, a review. The encoder will understand the English sense, and the decoder will generate the translated Spanish sense. But what if I told you we can also use only a decoder-only transformer for language translation? In fact, how is a decoder-only transformer's main behavior of predicting the next token this powerful and awesome? It almost seems like magic, as I mentioned before. Well, we will go over how in the large language models or LLM section of this course. That's it for this video. Thanks for watching.